Hello and welcome everyone. Very happy that we are all together again. In this tutorial we will talk about the tracks of the protection system. So fasten your belt and let's get started. The aim of this tutorial is to learn about the different tracks or the different modules that the protection system is responsible for handling, as there are some main aspects that we must study to explore the protection system and its responsibilities in the power system. So let's go ahead. First of all, if we need to understand what are those main aspects that we study in the protection system, we say that the first aspect is the study of the protective relays themselves and their design. As we learned before, the relays are the brains of the protection system as they receive the signal from the voltage and the current transformers, and then they take the decision of cutting the circuit or not by sending some signals to the circuit breaker. But those relays have some types according to the purpose that we need to use the relay at which. So the first study on the protection system is to study those relays and their design. So we need to know how those relays are designed and their principle of working, as each type of those relays has a specific principle of working according to its job, so we need to know how those relays are working. And we must know also how to set the setting of those relays, as each relay has some settings like the current value that the relay will give the order to break the circuit at which, as this current value represents a fault value, or also the voltage value that the relay will open the circuit at which, as this voltage value represents the critical value or the fault value. So we need to study all of those modules and the protective relays. But as we said, those relays have some different types according to their job, like the overcurrent relay, which senses the increase in the current in the circuit, like that one here, and also the distance relay, and that type of relay's principle of working depends on the distance between the faulty section and the position at which the relay is installed. And also we have the third type of the protective relays, which is the differential relay, and the principle of that type of relays is that it works by comparing two electrical quantities in their magnitudes and their phase angle. So by comparing them, we can know if there is a fault or not. And the differential relay is one like that one in that figure here. Alright. Also, the fourth type of relays is the overvoltage relay. And that type works to detect if there is an increase in the voltage through the circuit that we detect by setting the relay on the fault value. So if the actual voltage value through the circuit reaches the fault value, at that case we know that there is a fault in the circuit, so the relay will send a signal to the circuit breaker to trip the circuit at that case. Very good. So that's about the first track of studying the protection system, at which we study the protective relays themselves and their principle of working. Now the second track of studying the protection system is the apparatus protection. And at that track we study the protection of the devices themselves. So we are talking now about the apparatus or the devices that we need to protect themselves. And for that, the first thing we need to know is which are those devices that we need to protect. Here, the first kind of electrical devices we need to protect is the transmission lines, as there are some faults which occurs in the transmission lines, so we consider the transmission lines to be one of the most important components that we need to protect. And then we have the feeder protection. So for the distribution feeders that are used to distribute the electric power for the different loads or for the different areas, we need to protect those feeders also from any fault which may be caused on them. And after that we have the transformer protection, as there are some faults which may be caused for the transformers, so we need to protect the transformers also. And also the fourth apparatus which we need to protect is the generator. So we study the generator protection as an important device in the power system. And also we take the motors into account for the protection, as there may be some faults which occur on the motors during its working operation, so the protection is responsible for protecting the motors also. And the sixth component we need to protect is the busbar. Here those are some copper busbars which are used to distribute the electric power through the three phases, or they may be used to connect the transformer three phases with the cables that are going out of the transformers. So there may be some faults occurring on the busbars like the short circuit condition, and we need to protect the busbars from those faults. Very good. But you can tell me now that it's a logical thing to have some protection elements like the relays to protect those devices which we just mentioned. And this is totally right, as to protect any device we need some protection elements like the overcurrent relays or the overvoltage relays. But as we said before, the study of the protective relays is the first study in the protection system, so we can conclude that the apparatus study is an application on the protective relays study. As if we have a specific apparatus, we may use some different relays to protect it. Here we have relay from the first type and another relay from the second type and another relay from a third type. So what we want to say is that there is a direct relation between the study of the apparatus protection study and the protective relays study. Alright, so that's for the first two tracks of a study in the protection system. And also the third track of a study for the protection system is the study of the global protection system. And the meaning of the global protection is the protection of the electric network that includes the grid inside it. Or the grid at that case is a part of the system that may have some problems or it may cause some problems to the system. And there are some special devices also that are used to detect the fault in the global protection system, like the under frequency relay, which detects the frequency when it gets under its rated level. And also the rate of a change of frequency relays, which detects the change of the frequency in the grid. And also we have the reverse of power relays, which detects if the direction of the power has been reversed. And also the voltage surge relays, which detects if there is a surge in the voltage signal, as the voltage surge is a very increase in the voltage magnitude at a very small time, so it's an instantaneous increase in the voltage magnitude due to some errors in the network. Very good. And an example on the global protection is the islanding problem, and the islanding problem is a case at which there are two sources for feeding the electrical load. The first one is the grid, which is the main source, and the second one is the distributed generators. But the problem is that there may be an error in the grid, which makes the grid to be cut out, or there is no power that is going out of the grid now. So we need to disconnect the generators immediately, as it's a very dangerous case to have the distributed generator which feeds the loads only. And for that reason, we need the protection system to sense when the grid is getting out of the power system. Hence, the protection system will force the generators to turn off also, not to harm it. And we can illustrate that islanding concept also by that diagram here. As you see, this is the grid that supplies the electric power to the loads through the transformer, but we have this distributed generator that contributes in supplying the loads with the electric power. And as you see, the generator is coupled with the grid at that point, which is called the point of common coupling. And now if there is any problem in the grid which makes it to get out of the power system, so there is no power from the grid to the loads, here this is a danger case, and at that case the generator must be turned off also. And this protection operation is done by a relay like the rate of a change of frequency relay, as this relay senses the change in the frequency of the power flow. So when the grid is getting out of the power system, the frequency of the power will change, hence the relay will sense that change. Then the relay will send a signal to the generator to stop its working operation. So that's about an example on the global protection at which we have the grid to be a part of the problem in our system. More than great. So that's about this tutorial at which we explained the different tracks of the protection system. Hope that's clear right now. Thank you for watching and see you next tutorials.